Now, please welcome to the stage Srikanth Thirumalai, Tessa Lau, and Jonathan Hurst for the panel How to Train Your Robot, moderated by James Wilsterman.
Hello, and excited for this panel. Always fun topic, talking about robots. We are exploring the AI hardware and data challenges that exist when building robots to operate in real-world environments. We are lucky to have such a distinguished set of robotics experts here today. Here with me is Srikanth Thirumalai, Vice President for Onboard at Waymo in engineering. Tessa Lau is the founder and CEO of Dusty Robotics and has been in the AI and robotics industry for over 12 years. Jonathan Hurst is the co-founder and CEO of Agility Robotics and a professor at Oregon State University, where he co-founded their robotics program. Thank you all for being here. And please, you are all deploying actual robots in the real world, so please go down the line a bit and kind of brag a bit about that. It's pretty awesome accomplishments. So Tessa, maybe starting with you.
All right. Hi, everyone. My name is Tessa Lau. I'm the CEO and founder at Dusty Robotics. Dusty creates construction robots that help build the buildings that we live, work, and play in. Our robots, you can imagine them as little vacuum cleaner-sized robots that drive around on construction sites and print blueprints on the floor. That bridges the gap between the digital design of those buildings and the actual physical work of building those buildings. We have over 100 robots deployed all across North America.
Great. I'm Jonathan Hurst, and Chief Robot Officer, co-founder at Agility Robotics. So we build this robot, Digit, and it is roughly humanoid, though I like to call it human-centric so that it can be multi-purpose. And you may have seen it most recently. It's on the cover of last week's Time magazine. I was very excited about that. But our real claim to fame right now is that Digit is the first humanoid robot in history to go do something useful in the world, where useful is defined as somebody pays for it because it's providing value for a customer. So Digit is deployed at GXO, part of the regular day-to-day work, and on a regular 3-year contract. And this is just the beginning of something that's going to be a really, really big deal going forward.
Srikanth.
Okay. Hi, I'm Srikanth. I work on onboard systems at Waymo, which is kind of the software that drives the car. Waymo, we offer rider-only rides in 3 cities, San Francisco, Phoenix, and LA. And our autonomous vehicles, we recently announced that we offer about 150,000 rides, so paid rider-only rides every week. And we're currently driving over 1 million miles, rider-only kind of miles, every week. And we have a few announcements that we've made recently. We're going to expand to new cities like Austin and Atlanta with partnering with Uber, where you can get Waymo cars through the Uber app. But the product itself hopefully needs no introduction. You can, if you walk around SF, chances are you'll bump into a Waymo.
Hopefully not bump in too hard.
Or at least encounter a Waymo or see a Waymo, yeah. Hopefully not bump into one.
Tell us a bit about maybe a lot of people here coming from the AI, ML industry broadly. Like, what would be some surprises or misconceptions if they were to come into the robotics industry and AI and robotics there?
Well, I can share one of my experiences coming from a general AI software background and coming into robotics for the first time. The biggest surprise for me is that hardware is flaky. It breaks in ways that software doesn't. And so as you're designing robotic systems, you have to design for a lot of more possibility of error that are non-deterministic, chaotic errors than you did if you're building any kind of software system. I actually suspect the same might be true of AI, but I don't know if we have enough experience with it yet.
What I would say is most people have experienced in conversations who are thinking about AI kind of say, well, now we have this human context. Now we have the ability to understand what is in the environment, how to perceive it, and then you can just say, okay, robot, pick that up and put that over there. We're done. That's the solution to the problem. But actually what Agility Robotics has been doing for a decade, what I've been doing for 20 years, is below that. It's like, okay, you want to grasp that thing, or you want to go here. How do you take in the complex sensor data, do the algorithm to do the complex dynamical behaviors to do locomotion, manipulation, and loco manipulation in the world. So it's like the AI that that's really exploding right now is how you create IKEA instructions for how to assemble a piece of furniture. And then what I'm really interested in, what's also a very, very hard problem, is actually grasping the screwdriver and actually holding things and sticking them together and then following the IKEA instructions to do that. That's a really, really, really big deal and a really significant challenge.
Yeah. So for me, I come from search. So I was in product search before I joined Waymo. And search is also kind of a long tail learning problem. You have search queries that you probably have not seen before in a search engine, and you have to provide good search results. Autonomous navigation is also a long tail learning problem, right? You encounter rare and hard situations on the roads every day, and you have to figure out how you're going to navigate in those scenarios. But that's where the similarity ends. Let's say you have an irrelevant search result, no big deal. You have a chatbot that hallucinates, hopefully no big deal. But if that sort of hallucination results in a collision in the real world, it's a huge deal. And so for me, I think coming into the space, it was like safety is important, but seeing the ways in which your software, if it messes up, the consequences of that was a huge eye opener. So anyone who says, "Oh yeah, robotics is just another application of AI," well, you haven't really dug into the problem to understand how complex it is. Turns out that the real world is extremely messy. And this is arguably one of the hardest problems, in AI right now, in my opinion.
Yeah, safety on physical robots is a whole nother level, a whole additional, technology blocker that's on the same scale as any of the hard technology problems that we're tackling right now. It's a big one.
But on the other hand, if it works, you're actually doing something real in the real world, which software can't really
That's
do.
right.
I feel like you all chose pretty hard settings, like construction, factories, and roads with fast travel.
What other settings are there for physical?
I don't know. I mean, there's the home is interesting. Maybe Jonathan, from the humanoid perspective, could that be safely done? Is that possible?
It's certainly possible, but it's a long road. You got to get to the point where you're comfortable having call it a 200-pound device that is able to lift 30-pound, 40-pound objects, which is a lot of strength. You're comfortable having that around your children. And are comfortable having it make decisions about how it's going to make contact, or if it's going to fall, how is it going to not fall on your puppy?
Yep.
And there's a path. You have to go through the industrial path and OSHA and regulatory environments and all of that to get it right first.
That's why we started in construction, because everyone's wearing hard hat and steel-toed boots.
Smart. So tell me a bit about training robots. Very hard for all the reasons we just talked about. Are there other kind of parallels maybe you see happening in the AI labs foundation model space where they are running into training challenges where you maybe have already seen that in robotics?
Well, Srikanth and I were just talking about kind of the difference between data-driven approaches and simulation-driven approaches and where these two approaches are appropriate. The data-driven approaches is where you kind of need human context and so on, but for a physical robot, you kind of have to explore things in simulation if you're going to discover in the first place how you even control something.
Yeah, and the way we've approached it is, exactly. So focus on the data, focus on, the quality of the data that we train on. And, kind of over the years, Waymo has bootstrapped itself using a variety of data collection strategies. Of course, there is manual driving, driving miles with a safety driver. Even as you grow the number of miles you drive on the road, learning from the miles that we drive rider only, but that's not sufficient, and you have to sort of generate synthetic scenarios to augment your training data, run simulations to see how your car performs in those scenarios, and really, I think simulation is, as Jonathan said, a super vital problem for robotics, and getting realistic sensor simulation, realistic behavior simulation, really simulation that realistically evolves the world for the car. I think that is the holy grail. And once you have that, you could sort of closed loop train your robots and sort of start getting better and better at performing these tasks. But that is a core area of research right today, and everybody's trying to get to that world model, as Jan LeCun says, that understands the world, can simulate the world, right, in ways that your robots can effectively learn.
Today, can you create sort of novel events in that simulation, or do you only need to discover those rare events from actual real-world application?
I don't know. For us, we're starting to do that. I mean, it's not sort of like out there and common practice, right? But there are sort of labs that are trying to through various advanced technologies, like maybe controllable diffusion models, or generating these scenarios and controlling them through through language, right? To see how realistically you can create these scenarios and use that to train your models. But I don't think this is still in the mainstream today.
And Tessa, you're opting more for a traditional sort of software-driven approach to the navigation currently. What led to that decision? Was it part of this data availability issue?
Well, I've got two thoughts on that. So I think the reason we've seen such rapid evolution of AI models right now is because we have all of this corpus of data to train off of the internet, right? And the challenge with robotics, as we know, is that there's a lot less data about the real world that we can actually train on because it's not been captured. And so in Dusty's case, when we started building this 6.5 years ago, all of this stuff didn't exist, the data didn't exist, and the models didn't exist. And also, not just that, but we're building essentially a power tool for construction. And you don't want your power tool to be non-determinate, right? You want it to always do the same thing every time you turn it on and make it go. And so we've opted to essentially bake in the algorithms that are underlying our system because AI is still, I think, a little bit unpredictable.
You've got a digital twin. I guess all of us would have what we call a digital twin, that our robots operate in a simulation to create the synthetic data to explore all the behaviors that the robot could do without breaking the robot in the real world first. And I would say that a lot of the corner cases that we see from the robot that's been deployed is kind of human-in-the-loop learning for us to upgrade the simulation so that we can continue to do this randomization and dynamics randomization and figure out how to handle all of the kinds of weird things we'll see.
Jonathan, is it helpful in the humanoid robot case to have teleoperation data where humans are controlling the humanoid robots to generate data?
I think that teleop is way less useful than most people assume it will be. Because even if a robot looks like a person, that's maybe biomimetic, it's probably copying the wrong properties and the wrong things. So certainly the dynamics of a robot and how an individual finger works and the compliance of the interaction with the world, that's so important for how we interact physically with the world. Robots are not good at that, and we don't understand it from a scientific fundamental basis yet. So you have to keep it simple. Maybe teleop gets you in the right vicinity to start a reinforcement learning process, to start actually figuring out what the controller is for that robot. But it is not a source of data that you can actually use to train behaviors that are going to be robust or useful.
Totally agree. Having been through 2 robotics companies at this point, I think teleop is a crutch. Because if you're using it, then you're not actually solving the real problems that you need to solve to get full autonomy.
I feel like the people who use it, who are really experienced roboticists, will say, yes, I know it's a dead end. Yes, I know it's not that useful, but it's kind of all we've got right now for this demo thing we want to do.
Got it. Makes sense. And moving on to kind of, the future of this a little bit, moving forward in time, like a lot of robots and AV systems, many of yours here are using like modular systems, multiple algorithms, models all operating together. Like, will we move into more of a generalizable end-to-end system, or is that possible in robotics, or is it even a good idea?
Yeah, I mean, this is the hot area of research these days, and we recently announced an end-to-end modular, end-to-end multimodal model for autonomous driving called Emma. And what Emma is a vision language model that sort of like is adapted for autonomous driving. So it sort of takes in the environment through cameras, and using sort of language, it sort of is able to understand the scene around it, get a good sense of the road graph, the map of the streets. It's able to see the objects around it. It's able to reason using chain of thought reasoning about
does it have a world model? Like it reasons, hey, I'm seeing this is a tree. And
yeah, so it's sort of like it's a small step towards being a world model.
Okay.
Right?
Do you know what's going on inside of the black box?
Yeah, so this is really important, right? Because if you have a truly sort of end-to-end model that's just basically saying no all the way from the encoders to the decoders, I'm just going to pass representations that aren't simulatable, right? Then you really need sensor simulation to simulate, right, how the world is going to change based on the actions of the car. But if you start grounding it in physical objects, other physical things in the real world, you could sort of do simulation using those physical objects. But it's a can of worms that you have to contend with. But this is again why some of these end-to-end models are in a research state, if you will. But until we actually solve the problem of realistic sensor simulation or realistic behavior simulation, they'll probably just be research prototypes.
And maybe Jonathan, on the humanoid side of that, does that make sense? Ever have an end-to-end model or using vision capabilities?
I think it's always going to be an engineered system. I think there exists inherent structure in ways that we understand really well. And just to give an example of that, at the lowest level of control, it's you know how to do inverse kinematics and you know how to control your joints. But you don't need to know about the map of the room or the context of what is a liquid in a glass. And you have to do that control very, very fast, high control rate. At a much higher level, you don't care about the low-level details. And just having that differentiation, it shows up time and time and time again in biological systems. It shows up in every engineered system. So if somebody was able to have some system that could just do end-to-end and create that entire engineered system from scratch, that structure will still have to exist somewhere in there. And imagine the complexity of saying, build an AI system that is going to design a car. That's the level of complexity that I think people are asking for with end-to-end
control. With the end-to-end model, yeah.
And I think that just the intelligence that people have in creating a system, using the right tools in the right places to create this system, which are going to use all these different tools that are under the big umbrella of AI, is super valuable, and that's the way it's going to go. But it's going to be a lot of engineering.
Yeah, the latency point is very interesting, right? As you add more capabilities to the generalizable model, you're probably sacrificing some of the latency needs of robotics.
Yeah, but it hasn't to be. It doesn't have to be one or the other.
Sure,
it's not
both.
binary, right?
Yeah.
You can make progress towards that world without sort of saying, well, it's end-to-end models or bust.
Yeah, there's no reason to be dogmatic about it. Use lots of little black box models throughout your system and build a whole hierarchy on them.
Are you being sarcastic, or are you?
No, honestly, that's what I think is the right answer. I mean, any AI approach is about sort of describing the symptoms or the outcome that you want from a system and then trying to steer it to solve it and come up with a representation that would be hard to do with an engineer writing an equation or something, right? And so you want those black boxes to be things that are extremely well defined. So you know exactly how they're going to behave and you can train them sort of completely. And I think different tools apply at different layers of that, hierarchy. And it will be an engineered system of lots of these kinds of small boxes.
But you can get to a safety perspective that you're comfortable with these black boxes in deployment. Yeah.
It takes statistics and hours, but yes.
And Tessa, you have this purpose-built robot for particular use case in construction. Are you optimistic about humanoid or generalizable robots in that environment, or are you thinking, no, the future of robotics and construction industry is these purpose-built robots?
I am 100% purpose-built. If you think about it, the task that our robot automates is one where people are bending down 1,000 times a day in order to use measuring tape and string to mark lines on the ground. There's no reason to build a humanoid robot that replicates that person doing that task. A purpose-built robot is always going to be like 10x or 100x better than a general-purpose robot. There are use cases for general-purpose robots, but not for these really mission-critical tasks where accuracy and predictability matter a lot.
How do you feel about that, Jonathan, from the humanoid perspective in a factory environment?
I mean, I think Tessa's right. And I also think, like, we don't want Digit to be carrying boxes across the warehouse. Like a forklift or a pallet jack or an AMR is going to be better at that.
Great.
A humanoid robot is great for human workflows, where people are doing robotic tasks, and you now want this automation. Or the robot has to exist in human environments, like delivering packages to your front doorstep. That will always be a human environment with gates and stairs and things like that.
Unpredictability.
Yeah, but the other thing I want to point out is, to a certain extent, any successful business has to build a purpose-built machine, because there has to be a problem that you're solving, and that means there's going to be a set of requirements and metrics on those requirements that you need to measure to see how successful you're being, and so customers can see what the value is that you're bringing, and then your machine has to solve that problem, or several of those problems, you know.
So when will we all have humanoid robots in our houses? Do you have any prediction there?
I'll let somebody else predict. I think it's going to be a while before they are in our homes.
Got it. And Srikanth, I use Waymo very frequently in San Francisco, and I'm curious about the economics. Like, this is, a commercial product operating in 3 cities, like you said, and I'm curious, like, will we reach a point where the economics are just extremely competitive with existing human-driven ride-hailing systems?
Well, I certainly hope so.
Is that the goal? Yeah.
we don't talk about
Sure.
we haven't shared any information about that, but we're working very hard to reduce the cost of our our next gen platform is a good example of our efforts to rein in costs. It is much more cost effective to run our next generation platform as it is this one. So we're working hard on all of those things, and we certainly hope that this is going to be a commercial.
It seems like you're going for very wide adoption scale coming ahead in the next few years.
Yeah. So that certainly helps to some extent, because it amortizes the fixed costs over a much larger fleet. But there's a lot more to that.
Great.
I wanted to add something about the in-the-home thing.
Sure.
So right now, the way that we do safety is, first, we have to identify a person reliably and statistically in a way that can be certified. And then our robot basically needs to get down on the ground before the person can touch it. And that's because it is so unpredictable, given that the robot can apply large forces, how they would apply those forces to another person. In order to have robots be safe around other people, the intelligence is going to have to be so high and so reliably high that the robots even have social norms about when and how they would touch a person, and when is appropriate to, and when they could cause damage. And how are you going to avoid a robot with fingers from poking somebody's eye out when you have 100,000 robots deployed interacting with people 8 hours a day?
It seems like it won't be a very fast transition. The cultural aspects of this need to be developed.
Yeah.
Well, yeah, and that the slow process of building up the hours, the many thousands and millions of hours of statistical, gradually moving your way out is what it will take to do it safely in homes.
And so what I would add to that, I think, where humanoid robots have potential is where the tasks are not well-defined, because that's what we're good at, right? And our form factor is very versatile. We can do a lot of things with our 2 arms and our 2 legs. The problem with the robotics business is that you have to create a business. You have to make money.
Yeah.
And if you don't have a well-defined task, it's really hard to make money off of it. And that's why I believe that the purpose-built robots, that's the way we're going to get to the future that we want to see.
Thank you to our panel.
Yeah.
Appreciate it.
Thank you.